Good morning. As a contribution to the BCO project meeting, we'd like to share with you some insights from several projects we are running or are involved in, ranging from the NIH PD2K BioCADI project, but also the European Union Innovative Medicine Initiative on Translational Research called ETRICS, as well as many projects such as ISA, a multi-omic data management framework, and Elixir UK supported biosharing registry of standard. So why are we so keen to contribute to the BCO project? The answer mainly lies in our involvement in the development of the BioCADI DataMed project, aiming at producing the equivalent of PubMed but for datasets. DataMed is a prototype for indexing and searching datasets. As per the latest release, over 60 repositories have been indexed. These encompass both primary and secondary resources. For such latter case, it means that indexing the reanalysis and meta-analysis of existing datasets. In such context, allowing scientists to discover tools, analytical tools, is becoming a key issue and also a key driver. For translational research, being able to understand how a dataset has been produced matters, and having the ability to search and discover workflow matters even more in the context of reproducible science. So what are the lessons we've learned from BioCADI? So BioCADI DataMed relies on a model known as the data tag suite, which defines a number of objects and constructs of relevance to the definition and declaration of biocomputer objects. Two cases stand out. One is to make sure that the biocomputer object terms and use are fully captured, and that provides license and right construct to do so, both on a legal and technical standpoint. And two, that provides a means to report various different distribution modes, so the different formats and location of the workflows. Finally, that provides a mechanism to indicate compliance or conformance to annotation standards, which may be useful to assess the quality of a said workflow. So reuse of that element could facilitate indexing through the DataMed system, and therefore enhancing the discoverability and potential reuse of any given workflow. So we ought also to tell you about our interest in BCO. This stems from work that we've been carrying out for a European project named ETRICS, part of the Innovative Medicine Initiative, focusing on translational medicine. We produced a document known as the ETRICS Standard Starter Pack, following an extensive review of use cases and needs for the pharma industry around the topic of data management standards and data curation efforts. Working with key standard development organizations such as CDISC, but as well as grassroots academic initiatives phenotyping, the consortium has issued a set of recommendations on standards for use and guidance to all IMI projects operating in the field. The document and the associated recommendations are regularly updated to reflect changes, addition, and enhancement in the standardization efforts. Hence, any outcome of the BCO meeting on how to manage an analytical workflow is likely to be of relevance to our audience. So we simply like to share with you some of the lessons we learned with ETRICS and during the review process. Well, the first observation from inspecting the current specification of the BCA, it is possible to identify specific needs around semantic annotation and markup. The most important thing would be, therefore, to identify key semantic resources and, above all, mandate their use. With over 600 resources listed in vocabulary servers such as BioPortal or OLS, leaving complete freedom may not be the best route to follow. Instead, clearly mandating the use of a small number of key vocabularies, for instance, what can think of EDAM, which has already been used to mark up file format and workflow, but also consider Stater for annotating statistical tests, metrics, and quantitation types. It would clearly identify accretion points where discussion around use cases and query case could happen, define standard operating procedures for term request and issue tracking. Furthermore, it would allow the definition of curation practice and implementation patterns, reducing the annotation heterogeneity and mapping pains. All of this would contribute to make the biocompute object fair objects. Finally, the last experience we'd like to report is a collaboration between the Research Object Project, the ISR model, the use of Galaxy tool, and the Stato terminology. In an exercise in reproducibility, we published a work in PLOS ONE in 2015, and the key messages we'd like to convey are the following. 1. Use the right tool for the right task. Arrow was good at providing a wrapper to bring disparate things together. ISR was good at capturing key information about a study design and the relation between entities, and Stato was good at providing the proper semantic markup to describe anything related to statistical tests, confidence limit, and errors. So thank you for your attention. I hope that this small, short presentation will have provided a useful insight. So let me finish with wishing you a great meeting and very productive and fruitful discussions. Thank you.